at how to figure out the determinants of a matrix, especially if the matrix is of size more than 3 by 3. And we are going to learn a method called Cofactor Method, and which is a you can learn the details of the method when you pick up the linear algebra class down the road. Right now I will just explain how to use it. So we are going to consider a 3 by 3 matrix, and to find a value associated to a matrix is called determinant. And the way to find it is it depends on which row or which column you're using. But actually, it really doesn't matter which one. So if you just make up your mind, for example, we are going to start, we are going to use the first row. So the language that we are going to learn to use is we are going to use the first row to expand the determinant. And the way to do it is, say the first row, you have entries A, B, C. For each entry, each entry will be associated with a term called minor. And minor actually is a determinant of a submatrix formed by deleting, that means take away, the corresponding row and column. So what I mean by minor for the A is the following. Okay, so if you're going to use A, the minor for the A will be you're going to take out the row corresponds to A and the column corresponds to A. So the remaining submatrix will be EFHI, and you just need to take the determinant. B, if you're going to look at B, so B will be my next one. And let me change my color. So if it is B, you're going to delete the row for the B and the column for the B. So the remaining submatrix will be DGFI, and you set up the determinant. Okay. And now for the C, you're going to delete the row for the C and the column for the C. So the remaining matrix will be DEFGH. So this way, after you set up the minors for each entry in the row that you are using, then the determinant of A will be the following. Will be always the entry, because the row that you pick will be the first row. So it's always the entry A times the corresponding minor, and B times the corresponding minor, and C times corresponding minor, but then you need to either add or subtract. So turns out if you start from, and also one last thing is each entry will be associated with a sign, plus or minus. And the first entry in the matrix A is always a plus. So you just have to count the signs, and they change plus minus in the alternate form. So plus minus, and so on. So A will be positive and B will be negative and C will be positive. So the determinant of A will be defined in such a fashion. Now if we are going to multiply expand the 2 by 2, because we already know what to do with 2 by 2, then the determinant of A will be the entry A times EI minus HF minus B times the quantity DI minus GF plus C times the quantity DH minus GE. And you just distribute A, B, C. So the determinant actually will be the 6 terms that we are seeing. If you are going to use a different row, different column, actually you can backtrack. So it's still the same 6 terms. So it just depends on which one, which row or which column you're using. So the idea will be the same. So this is called the cofactor method. And the cofactor method works for 3 by 3, 4 by 4, 10 by 10, any sizes using this way. But the higher the dimension of the matrix, the size, then the more tedious will be the process to find the determinant of the matrix. So let's try one right away. I set up a matrix called 2, 5, 6, negative 3, 1, negative 4, 1, negative 7, 1, and I said use row 2. So if you use the row 2, okay, so the entry will be negative 3, And I set up for you, so it's a -3. And the minor will be, you cross out the second row, first column, so the minor will be 5, 6, -7, 1. And then the entry is 1. So you cross out the second row, second column, so the submatrix will be 2, 1, 6, 1, right here. -4, cross out second row, third column, you get 2, 5, 1, -7. How about the signs associated to each entry? 2 is plus. So -3 is a minus. So 2 negative plus negative. So that's why -3, you put a negative in front and then plus and negative. And now you're going to simply expand the 2 by 2. So double -3 will be +3. So 5 minus a -42 will be 5 plus 42, which is 47 times 3 is 141. 2 times 1 is 2 minus 6, so it's a -4 times a 1 is a -4. 2 times -7 is a -14 minus a 5, so it'll be -19 times a +4, so it'll be -76. So 144 minus 4 minus 76 is 61. Okay, another example. And 7, -1, 2, 0, 6, 1, -4, 5, -3. I said use column 1. So if you use the column 1, write out the entry 7, 0, -4, and then you are going to cross out terms. Sooner or later, you don't need to show yourself all that work, but the first few times, they make it really visually more easily. So 7, cross out the first row, first column, so the remaining submatrix will be 6, 1, 5, -3. 0, cross out the first column, second row, so -3, 2, 5, -3. 4, so the submatrix will be -3, 6, 2, 1. Signs, because I'm using the first column, so 7 is a plus, negative, plus. So plus, negative, plus. And you expand the 2 by 2. So 6 times -3 is a -18 minus a 5, so it'll be -23 times 7 is -161. 0 all goes out. -3 times 1 is -3 minus 12, so it'll be -15 times a -4 is a +60. So the answer is -101. Okay. Example number 3, using the third row, 5, -9, 7. Cross out the first column, third row, so the submatrix will be -1, 8, 3, -4. -9, cross out third row, second column, you get 2, -3, 3, -4. 7, cross out the third row, and 7 actually should be the middle column. So wait a second. Just fix it. So 7, you cross out the third column's last row, so you get 2, -3, -1, 8. And then signs, because you're using the third row, so plus, minus, plus. So the sign will be plus, negative, plus. So plus, negative, plus. So you have -1 times a -4 is 4 minus 24. So -20 times 5 is a -100. -8 plus a 9 is a 1 times 9, which is a 9. 2 times 8 is 16 minus a 3. So it'll be 13 times 7 is a 91. Whoops, when you add them up, turns out to be 0. The determinant is 0. Okay. Another example, 4 by 4. Whoa. Well, the method will be the same. It's just a little bit more tedious. Why? You will see. I said use column 2. And the reason why you pick column 2 now is because you have 2 entries with the zeros. So from now on, you don't just use column 1 or row 1. You try to use the row or column with the most number of zeros. So that's why I picked column 2 for you. So if you pick column 2, write down the entries 1, 0, -2, 0. And learn to do the submatrix. So cross out the 1, cross out the first row, second column. So the remaining entries before -6, 1, -3, 0, -1, -1, 8, 3, right here. Second entry, cross out the second column, second row. So it'll be -2, -6, 1, and so on. But then it's a 0. Oh, so I didn't even write it down. And then -2, So cross out the third row, second column. So you have negative 2, 4, 1 right here. 5, negative 3, negative 1, 2, negative 1, 3. Last entry here is 0, so I don't bother to write down the submatrix for you. Signs, plus negative, so the first entry starts with a negative. So that's why it's negative plus negative plus. Now you have two chances to use the cofactor for the 3 by 3. So that's why it's tedious. Now you know. So for the 3 by 3 here, I keep track of the negative 1, but put up a big bracket to keep track of the 3 by 3 determinant. And now, as you can see, I'm using the second row. Or you could use the second column, but I use the second row. So negative 6 times the submatrix plus 0 minus 8 times the submatrix. Why negative in front of the negative 6? Plus minus. So the negative 6 is a negative. So negative plus negative. Next one, double negative times a 2 is a 2. So for this matrix, it doesn't matter which row, which column. You don't have any zeros. So as you can tell, I use the first row. So be negative 2 times the corresponding submatrix minus a 5 times the corresponding submatrix plus a 2 times the corresponding submatrix. And now just really carefully, okay, as you can tell, I'm very careful in copying down the steps. So this will be double positive, negative will give you positive 6, negative 9 minus a 1 right here, negative 8. When you multiply negative 4 plus a 3 right here, plus 2 bracket, negative 2. So this is negative 9 minus a 1, minus 5 times 12 plus a 1, 2 times the quantity, negative 4 plus a 3. So make sure you keep track of all those numbers, and the final answer will be negative 42. So now, of course, you say, gee, how do I know I have a correct answer? Well, you should know how to answer your own question. It's either you pick another row, another column to repeat, or calculator time. So for the calculator, you are going to, I will use this as an example. You go to the second matrix, go over to the edit, and since your A is 4 by 4, so you enter 4 and hit enter, enter 4, so that's the size. And I already put the entries in for you. And now you're going to, okay, go out to the calculation screen because you're looking for the determinant. So where's the determinant key? Second matrix, go to the math. First one, determinant. So you hit enter, so the calculator will get you the determinant, but you need to put in the name of the matrix. So it'll be second matrix, and I store it under A. Close the parentheses. When I hit that enter key, what do you think? What's the answer? Negative 42. Folks, now you know. So I already did the screenshot for you. I also have the answer for you. And for the other problems on the other page, for example, number 2, I did this, store the matrix for you, and the determinant was negative 101. Second example, I store the matrix for you, and the determinant is 0. So folks, you don't really need a book nor any additional material. Just make up your own matrix, walk through the cofactor method, practice the number, and use your calculator to check the answer. Same thing for the first one. I believe I also have. This one is also only theory. Oh no, I have the screenshot for number 1 also. That's the matrix. And the answer is indeed 61. Okay. So again, I set a lecture for you. It should be a full lecture to walk you through from the theory to the exercises to the calculator. So things should never go wrong. And I will give you more example in the next podcast, also on determinant. and you will see why we need to learn determinant. So stay tuned. Quote unquote, see you in the next one.